Next on our agenda is a continuation of this conversation related to the challenges and opportunities for water utilities, in particular this time on wastewater treatment facilities in the era of COVID. Joining us today, we're able to hear from Christina Davenport about her city's wastewater treatment facility is assisting in predicting COVID outbreaks, as well as future opportunities for PVC piping materials in the city's vibrant craft brewing industry. Christina Davenport manages the City of Bend's industrial pretreatment team to regulated industries for compliance with federal, state, and local regulations. Christina also is a liaison for Brewing Industries, which involved improving, monitoring, and coordinating a brewer's workshop and advising other municipalities on high waste issues. Christina, thank you very much for taking your time for you this morning, and welcome to the Vinyl Institute's Vinyl360. Christina, are you there?
Hi, thank you for having me this morning. It was great to segue from Richard's presentation. I was just thinking we had a cast water main pipe break this week, and 750,000 gallons of water was lost there, so aging infrastructure. And I'm going to do a different spin kind of on COVID and how it's brought wastewater kind of to the forefront and some challenges and opportunities related to that and the growth in our city. So this first picture is a picture of Bend. I don't know if everyone's familiar with the city of Bend, but we are on the east side of the Cascades. So most people associate Oregon with Portland, so wet climate. The west side of the Cascades, we're actually high desert, but we're nestled against the Cascade Range on the east side. So go ahead, next slide. So just an overview of my presentation. I wanted to just kind of show a little bit about Bend and some of our challenges that kind of relate to our infrastructure and how PVC industry could actually help with some things. And also, I want everyone to pay attention as I go through our wastewater epidemiology and some special challenges that the PVC industry can help with actually sampling. This has come up in industrial waste too, some challenges we have with manholes and such. A little bit on the industrial pretreatment program, what that is and why we work with breweries, concerns for infrastructure in our community, and then the special use of PVC because we have some special wastewater characteristics and challenges. And then hopefully some time for questions. I'm covering a lot and switching gears, so I'll try to get through it pretty quickly. Next slide, please. So first, this is a great little video just to show you a little bit about our town. Cute little mountain town. So if you can hit the video, love to show you where I'm talking. As you can see, pretty cool town. So part of what's come out of COVID and the new Zoomer population, so these people that have figured out they can telecommute from anywhere, we have been ranked last week. They talked about Zoomer communities, and I think Missoula, Montana was #1 with a 20% change in housing sales from last year, and we're at 15%. So we are growing so fast. We've already been growing fast for the last 5 years. We are definitely, I think we were the second fastest growing city in the country this year. So with the change in COVID, that's just added pressure. So you can imagine the pressure on our infrastructure and rates and everything. We're dealing with a housing crisis. People are bidding, 50 to 90,000 over houses, and 19 people, bidding on a house. So just a little bit of what our city is facing as a result of COVID just put increased pressure on infrastructure. So I'm not going to go too much into the operational highlights. You can look at this slide yourself, but just kind of a look at the overview of our city. So we have some challenges with wastewater infrastructure, rolling topography. We're on lava. We're surrounded by volcanoes, so often lava at maybe a foot, 2 feet down. So that creates some unique challenges. You're either blasting to get pipe in, or you're putting in a lot of lift stations. So we ended up actually, with 480 plus lift stations. I think we might have more than that now. So I think we have the most lift stations per capita in the entire country, just because in the past history, they chose to allow developers to put in lift stations instead of blasting through the lava to lay the pipe, which we now know is probably a mistake. We should probably go with those gravity lines. So more to talk about that too, and how both brewing industry and the challenges as the community grows facing that. Next slide, please. So I want to start, this is our intake facility. So City of Bend gets our water from surface water and groundwater. So this is our surface water intake facility. So this water is coming directly off the Middle Sister Glacier, which is one of our volcanoes. So it comes really, you can follow a trail up this Bridge Creek to our source water, and it's just coming out of the lava. So very pristine, very clean water. It's 2 years ago, we finished a water filtration facility. So the surface water rules with EPA, we had to design and build a new surface water facility. And then the rest of our water comes from groundwater. So we do have a very good aquifer, deep water aquifer with 13 reservoirs currently. So we can shift in between the surface water and the groundwater. So I want to point out our water, because this is what makes Bend a good brewing industry and a brewing city. Next slide, please. And this is our waste treatment plant. So our waste treatment plant was in '96 when we built our new wastewater treatment plant. They placed it way outside of town in the desert. So it's a good location, no odor complaints, no one around it, and we have tons of land out there. They brokered a deal with the Bureau of Land Management, and I can't remember if we have like 150 acres out there, so a lot of room for expansion. Next slide, please. What's unique in Bend, which you don't see a lot in the country, and it again creates some unique challenges for us, we hold a WPCF permit instead of an NPDES permit. We discharge to the surface in the desert. So these are evaporation percolation ponds. So they're lined with bentonite, so they do percolate through the ground. So we have to meet groundwater quality standards instead of the river TMDLs. So that actually makes it a little more stringent on what I regulate, so industrial pollutants passing through. What's cool about this is these ponds that we create are actually an Audubon bird sanctuary. So again, we assure that the water coming out is very clean, so the final effluent discharging to this is clean. Next, please. So I'm going to switch gears now and talk about this new COVID thing. So when COVID hit, we had already been looking at what's called wastewater-based surveillance or epidemiology or forensic wastewater surveillance. So one of the first cities to use it was Cary, North Carolina, where they used actually chemistry to look at drug use within the community. So you can identify in the wastewater down to even specific brands of opioids, and it can guide public health and police dollars very clearly. It's not too invasive because, again, you're looking at multiple neighborhoods. You're not isolating a single home. What was able to shift quickly is with COVID, a company called BioBot was researching looking at viruses in wastewater to predict outbreaks. So they were on board to do this when COVID hit. we were one of the first cities to get involved in the study and reach out to BioBot and started submitting samples very early on. Because of what we were already doing in our industrial waste program, we could quickly shift to this. So the wastewater-based epidemiology, the idea behind it is that they can collect influence samples at your wastewater treatment plant, and they look for the viral RNA. And this can tell the prevalence of a virus in your community. And this is kind of an old technology. They've used it for polio. They actually use the polio virus to test treatment. It's kind of the standard. So it's not exactly new technology, but it's something that I think is going to grow in the future. So next slide. So they've already formed a partnership between CDC and EPA and started this wastewater surveillance program. So it's going to be a national program. We already have colleges across the country using it to determine whether students can come back into the dorms, whether they need to be moved into hotels if they see an outbreak. So it's an early indicator. You can, there'll be a copy of this, and then you can look at the CDC's website about the wastewater surveillance, and it's going to tell you a lot about it and explain in greater detail. So I'm going to kind of give a high-level view of it. Next slide, please. So we started out with BioBot, as I said, and then we had Oregon State University reach out to us when they heard we were working with BioBot, and they were interested in doing what we call split samples, so that we would take the same sample and send it to BioBot and send it to them to test a different methodology. So we said, sure, we'll sign on for this. The other cool thing about Oregon State study is they wanted to come and do trace study in Bend, which means go door to door and do nasal swabs on people. At the same time, we installed wastewater samplers to isolate the waste from those neighborhoods so we could compare the wastewater and then the test from the nasal swabs door to door. So super useful study. No one else had done that to this point. So it kind of looked at how that wastewater epidemiology was working. And now we are working solely with Oregon State. And so I want to go to the next slide and show you a video of kind of what we're doing, this little PSA that we put together.
In short, what we're looking for is the coronavirus signature in wastewater.
We already had the ability to test for other toxics within our sewer shed, so being asked to test for COVID-19 was not much of an add-on for us.
It's a very rapidly spreading disease, and so the fastest way that they can track it is actually through wastewater.
The idea is when people become infected with COVID virus, that they will shed it through the wastewater, even if they're asymptomatic. So this is a way for us to detect infected individuals, even if they aren't showing symptoms. And with a single sample, we can monitor an entire city or hundreds of people in a building.
So what we hope to have, and I think we're making very substantial progress toward this, is to have reliable early detection that would give us a signal before we were seeing an uptick in case numbers.
We set up composite samplers throughout the city at different points to create sections of the city that we can monitor and look at.
We pull up to the testing site and we install a sampler into the manhole. From there, once we grab our 24-hour sample, we then send that sample to Oregon State. They run their tests.
So the literature on this is fairly clear that in general we'll see a wastewater signature roughly about a week before you'll see other indicators such as increased hospitalizations, for instance, or increased cases documented by the local county health authorities.
We had one relatively large outbreak in a long-term care facility, and we were able to test wastewater in parallel with that and indeed confirm that the time that we had many cases, we were also seeing a detectable substantial rise in that signal. So the main thing that our department does is we've encouraged developing this as a potential early warning system. I don't know that it's quite developed enough yet to be reliable as such, but it should be a good way of finding out early if there's an outbreak starting in the community.
It's great for the city of Bend that they do have the forward thinking to be so innovative and to jump onto something that's new and quite possibly could be what's going to solve the next pandemic or help us predict maybe when a future outbreak will come.
Generally speaking, wastewater surveillance has been considered to be a leading edge indicator, giving you about a week's head start on when more infections will start showing up in the general populace.
We're doing research and development at the same time that we're trying to do surveillance and disease intervention and control. So doing all those together is very complicated. So we want to be honest about what we are learning and then distinguish that from what we hope to learn.
Once COVID came along, we partnered up with OSU, and they taught us how to properly preserve the samples for this specific test that they do for testing for COVID, for the PCR, RT analysis that they do on the wastewater to show the different viruses within the wastewater.
Through the Oregon Health Authority, we are now reaching out to over 40 cities across the state to start monitoring their wastewater on a weekly basis for the next 2.5 years.
The concentration effort in sampling that Ben Wastewater is doing, I think is very fruitful, and the work that OSU is doing in parallel with that is very fruitful.
Yeah, definitely it gives me a sense of pride that I'm helping keep us open and keep us safe, and if there is an outbreak that we can provide this information.
So as you watch that, the cool thing is I want you to pay attention to our sample manholes, how they were installing equipment in there. And that's something I'll bring up quickly at the end, where the PVC industry could probably help us make our sampling easier, more consistent. So I'm going to completely switch gears now from COVID and go into the brewing industry. So I mentioned, we have this great water in Bend. We've become known as a brew city. Again, like lift stations, we go back and forth with having the highest number of breweries per capita. That we kind of compete with Portland, Maine, and I think Portland, Oregon. So anyway, currently we now have 24 breweries, cidery, and a distillery, and kombucha makers. So we have a really thriving, what we call a beverage industry here in Bend. So next slide, please. I like to tell a little bit about brewery waste because there's a lot of misconception about brew waste. Craft brew waste is what I'm talking about specifically. In the wastewater industry, when a brewery comes to town, plant managers freak out. I'm like, well, why is this? Because most of them are pretty tiny. So brewery waste is one of the oldest industrial wastes. So this is a picture from a brewery in, I think, Cleveland. I think this is one I picked from Cleveland. So way back, this was before there were any metal finishers or steel manufacturing, anything like that. So you had breweries, dairies, and tanneries. So a very old waste, and it was very hard on polluting. They were direct dischargers into the river. So next slide, please. I choose Cleveland as an example for the brewery history because everyone knows the story of the Cuyahoga River and how polluted it was, and it kind of launched the Clean Water Act, which is what my program is based on. So the industrial pretreatment program came out of the Clean Water Act. Those regulations, Clean Water Act 1972 and the regulations for industrial pretreatment in 1974. So in the scope of things, in the world of wastewater, we're a pretty new program. Domestic waste or residential waste has been treated and recognized as a problem since the 1880s and even before. So this is kind of why it's harder to explain some of these things to people. So I go through the brew history really quickly to see how there can be misconceptions. So beer used to be cleaner than water, so even kids would be given beer. It was a lot weaker back then, I assume, but this is a good example of the water was terrible. And so brewing was a way to provide clean water. In the 1900s, Cleveland had 23 breweries with over 4 million gallons of beer brewed each year, and many of these were small family-run operations. Then you hit the 1920s, 1933, and all of that stopped. So because of prohibition, the brewing industry just went away. What came out of the brewing industry were these large brewers like Budweiser, Coors, Michelob. So you look at the difference, 9 breweries employing over 1,200 people. So you're looking at really big breweries. And that's what lasted, you can go to the next slide, until basically the 2000s when the craft brewing industry started. So craft brewers are much smaller generally. Our largest brewery in Bend is Deschutes Brewery, and it's a craft brewer. It's still considered small. They do about 500,000 barrels a day. The difference between a brewery of that size and something like Coors or Budweiser, they're doing about 6 million barrels a year. I think I said barrels a day, 500,000 barrels a year at Deschutes. So when you talk about wastewater plants, for a small plant, less than 1 MGD, we do have challenges if you have a big brewery. I know Newport, Oregon, Rogue Brewing is 80% of their loading. They're under a 1 million gallon a day plant. Larger plants should be designed to handle this waste because, again, it's conventional pollutants. It's what our plants are designed to take. It's just a lot of extra sugar and protein. So what plants often choose to do is impose surcharges for the extra treatment. And then brewery waste is what I'll get into, can be really hard on infrastructure. So next slide, please. And so in Bend, we choose a surcharge program. So we have, again, the legendary Bend Ale Trail. You can go around to all the breweries and get stamps and try and fill it up. I already touched on that, how many breweries we have. Next slide. Just brief what we're talking about in the brew industry. So if you look to those things to the right, the byproducts, in Bend, we try and side stream our byproducts and keep them out of the sewer. So the hops, the wort, and the trub. And at most of our breweries, that's side stream and land applied, or we have one brewery that actually mixes it with grain and sends it to an ostrich farm. All of our grain is used for cattle feed, so that's not a problem getting rid of the grain. None of that comes to the sewer. Next slide, please. So the problems with brew waste, biological oxygen demand, so very, very high. You can see numbers, if you have high strength brewery waste, that wort and trub coming to the treatment plant, you can see numbers as high as 20,000 milligrams per liter. So super high strength waste. Total suspended solids, if they're not doing a good job separating out the solids and there are a lot of solids coming down, you can have a big problem with that and clogging and just increased waste treatment costs. You can have extreme pHs, and so this is what's hard on the infrastructure, those manholes, and I'll show some what happens with the corrosion. So pH of 3 to 12, they clean with caustics and acids, so you can, and beer itself is around a 4 pH, so you can tell you get pH extremes. We see temperatures sometimes over 165 degrees. We have one brewery that's under a compliance schedule at the moment because we were seeing temperatures of 180 degrees. When you combine that with hydrogen sulfide, you get sulfuric acid formation in those manholes. So incredibly corrosive, even in the pipes. And I'll show some of what happens to our pipes in our lift stations. So again, the other challenge, capacity issues for the pipes and the plants. Do you have enough capacity in your lines? Can your treatment plant handle the increased loading? And then odor complaints. Brewery waste, it doesn't always smell great. Next slide, please. So this is Deschutes Brewery, our largest brewer, as I mentioned, around 500,000 barrels a day. Not a day, I keep saying a day, it's a year. So they are our only brewery that's actually under a permit because they discharge more than 25,000 gallons of waste to us a day. They're around 150,000 gallons of waste that comes to our treatment plant. And then they have 6 to 8 truckloads, 5,000 gallon truckloads of high strength waste that is land applied. So quite a bit of wastewater coming out of them. We did a unique project with them and installed this sampler inside their waste treatment facility instead of in a manhole. The manhole was not working for us because of some challenges with how you can get a flow monitor in. Again, that's where the PVC can help. Next slide, please. So why do we sample the breweries? Very important, and this is something that I kind of hammer on cities to really establish. If you're trying to grow industry, we heard of these challenges that might be facing us. I just talked to our economic development people on Monday, how they don't want to lose any breweries and they want to attract more industry to Bend. So using sampling data and understanding your wastewater characterization, super important to building these things called a maximum allowable headworks loading to your treatment plant and a maximum allowable industrial loading. And you can look at that slide with how much that affects everything in your community. And sometimes we forget, we get really siloed, and we forget how wastewater influences community development, economic development, how it affects a rate model, a surcharge program, and looking at resource recovery. The EPA has mandated that our programs look at industrial wastes as a resource and try to utilize them. Next slide, please. So here are some pictures. Some of them aren't great. It's never as good as actually seeing them in person, but you can see that pipe in the upper left-hand corner, a standpipe out of a lift station, and that was downstream of Deschutes Brewery. So you can see the corrosion that it causes. I think it was only like a year and a half old is what the collections guys told me. And so you can see the other pipes in one of the lift stations, and then the corrosion that just happens on the pipes, it just eats it away. Our struggle is, if you look in these manholes, what we're pushing for, and I'll get more into that about our unique climate after this, is to line the trenches with PVC, is what we're trying to get our standards and specs changed to with our engineering and infrastructure people, because we're having some real challenges with the concrete lined troughs. And so we started asking, why aren't they lined with PVC? So if you go to the next slide. So in Bend, we install sample manholes basically on any industrial or commercial property, with the assumption that a metal finisher could come in or whatever, a dairy, a brewery, so that we can actually sample for our program. The unique challenge of this, if it isn't an industry that has a significant volume coming through, we have a very dry climate. So that means if there's just waste products coming in there, what happens with the concrete, super dry, it gets cemented in there. And we ended up with septic tanks in our sample manholes. So we started coming up with this idea, and some people are doing it, where they're lining the sample manholes with PVC piping, and it helps because, of course, it's got that smooth surface. There's no drying of it because our super dry climate. And again, we have 480 pump stations. We also have really new building. We've been a fast-growing city in the last couple decades, doubled our population size. So a lot of green building, which, lower water use. And so we also have no combined stormwater. So we have little or no inflow and infiltration. We have a very aggressive water conservation program. So that makes our concentration of our wastewater super high. It's when we started actually sampling our residential wastewater, we recognize that it is at about 500 BOD, some places 600 BOD, so that's purely our residential wastewater. There were all these assumptions that the breweries were actually contributing a lot more loading to our plant because they were assuming our BOD was at 250 for residential. So we have really high strength wastewater, and there are other cities seeing this around the country. So in turn, not only is you have to plan your treatment plant for that, but you also have to think about these things like higher concentrations of ammonia, nutrients, and salts coming into your treatment plant. So, the positives about water conservation and green building also have this other side of the effects on the wastewater. So I really encourage cities to always really do aggressive sampling around their town. Again, the other thing when we look at the sampling that I was talking about, you saw our guys installing the flow meters and the samplers into the pipes. A lot of trouble we have with the PVC pipes fitting into the concrete where they've grouted around the PVC. We can't get those bands in. So again, that's another reason we're kind of pushing for our engineering people to require PVC lined manholes instead, so that we can easily get those bands in and not have to go down and chisel out concrete. It's hard to have an inspection program that catches all of those things. Sometimes they're grouting the troughs of those by hand when they install them too, so you can think of the friction in there. Next slide. And that's it. So I went through that really quickly. I'm kind of out of time. I know there's a break after this if people have questions, or happy to take emails or whatever.
Sorry, Ned, do you want to go? Or, hey, Christina, thank you. Wow, what a fascinating presentation. I need to go to Bend and see those pipes, but maybe try a couple beers too.
Yeah, we can take you on what we call the source to brewer to sewer tour. We'll take you through our water supply to some breweries and then out to the treatment plant, so you can see the full thing.
Awesome, awesome. Thank you. I do have a couple questions, if you've got a minute.
Sure.
One question was, what is responsible for the rapid corrosion of the iron pipes, and how does PVC present an advantage?
So that pipe that I showed was from a lift station downstream of a brewery. So with a large brewery like that, so we have a 5 to 11 pH in the city of Bend in our sewer use ordinance. So you can get these extremes in pH with brewing. So they clean their kettles with a caustic solution. So that's usually up around 12. And then they will come behind that with some sort of acid sanitizer. In Bend, the most common thing is hydrogen peroxide, a hydrogen peroxide, peracetic acid, and nitric acid mix. So you can see that those are very corrosive along with the really high temperatures quite often. So Brew Waste can be hard on a collection system. So just remembering that. And of course, PVC is not going to be affected like metal and concrete.
Okay. And then I think just one last question. Are you getting having any problems or pushback from the cement or iron folks in trying to make that switch? I mean, you mentioned that one piece of pipe was about a year old. That seems not very efficient.
Yeah, I think we've really worked on working with our breweries to try and improve their discharges to us, so that's helped. Our main challenge is what I mentioned about the manholes themselves, where PVC could be really helpful to line. I don't understand why that isn't just a common practice, because it would be so beneficial in our world for so many reasons. It would just make our sampling easier. And then that unique situation of sample manholes where there isn't a lot of flow coming in, it would certainly help with that. So as far as the other pipes, I'm wondering, I told you we just had this huge water main break that was a cast pipe. And I think we have a lot of aging infrastructure and looking at what is the best solution to replacing it. And again, the challenge for us is all those lift stations. I think it's a very unusual, most cities don't have 480 plus lift stations that they're dealing with. So really high maintenance costs and labor costs on that.
Right. Well, thank you. Thank you so much.
You're so welcome.
Presentation.
Thanks for having me.
Christina, thank you very much for that presentation. And I'm not surprised those ductile iron pipes are breaking like that. We hear stories like that every day of those ductile iron pipes that can't withstand the long capacity and durable products that we have out on our
and I don't know if this helps too. We have very huge temperature extremes. So we can get an 80-degree shift in temperature in a single day. So we can go from 12 degrees in the morning to up to like 90 in the afternoon. So very unique too.
So that's a perfect opportunity for PVC pipe, and feel free to go right in and tell everybody else it's PVC pipe or nothing in your area. But I really, the other thing I have to tell you is I think we have to schedule a future Vinyl Institute meeting in Bend, Oregon. I mean, 24 microbreweries and a distillery and 5 golf courses. That sounds like my kind of town. But for all of our friends in Cleveland and our fans of the Cuyahoga River who are in our meeting today, maybe we could do 2 back-to-back meetings between Bend and Cleveland, and we can compare their microbreweries and their wastewater and piping systems. So
yeah.
Thank you very much for your participation and joining us today.